Hello and welcome to my YouTube channel JK Academy India. In this chapter, in this video, we will discuss about the transformer having winding resistance. In an actual transformer, the primary and secondary windings have some resistance represented by R1 and R2 respectively. These resistances are shown external to the winding in figure. To make the calculations easy, the resistance of the two windings can be transferred to either side. The resistance is transferred from one side to other in such a manner that percentage voltage drop remains the same when represented on either side. Let the primary resistance R1 be transferred to the secondary side and new value of this resistance R1 dash called the equivalent resistance of primary referred to the secondary side as shown in figure A. What we did, we have transferred this R1 to the secondary side. I1 and I2 be the full load primary and secondary current. Then E1 into E2 by V2 into 100 equals to E1 E2 divided by V1 into 100, because this is the percentage voltage drop, or R1 dash equals to I1 upon I2 multiplied by V2 by V1 into R1. So as we know that V2 by V1 is the transformation ratio. Again, I1 upon I2 is also a transformation ratio. So this will become K square R1. Understood? So when primary resistance R1 is referred or represented in the secondary circuit, its value will become K square R1, where K is the transformation ratio. Now the total equivalent resistance referred to secondary, it is nothing but R2 plus R1 dash, so it will become R2 plus K square R1. Now consider resistance R2 when it is transferred to primary. Let the new value be R2 dash, called the equivalent resistance of secondary referred to the primary as shown in this figure C. So this will be your R equivalent. Then I1 R2 dash upon V1 equals to I2 R2 upon V2. Therefore, R2 dash will become I2 upon I1 into V1 upon V2 into R2. So this will become R2 upon K square. Therefore, total equivalent resistance referred to primary R equivalent will be R1 plus R2 dash, means R1 plus R2 divided by K square. So what we have seen, when primary resistance R1 is referred to R2, the total equivalent resistance will become R2 plus K1 square R1. But when we refer the secondary resistance R2 to R1, then the total equivalent resistance will become R1 plus K2 R2 upon K2 square. Now let's see the mutual and leakage fluxes. So far, it is assumed that the AC supply is given to primary winding of a transformer and alternating flux is set up in the core and whole of this flux links with both primary and secondary windings. However, in an actual transformer, both the windings produce some flux that links only with the winding that produces it. The flux links with both the windings of the transformer is called mutual flux, and the flux which links only with one winding of the transformer and not to the other is called leakage flux. The primary ampere turn produces some flux phi L1 which is set up in the air and links only with the primary winding as shown in figure A. This one, phi L1. Similarly, secondary ampere turn produces some flux phi L2 which is set up in the air and links only with the secondary winding is called the secondary leakage flux, represented by phi I2. The primary leakage flux phi I1 is proportional to the primary current I1 and secondary leakage flux phi I2 is also proportional to secondary current I2. The primary leakage flux IL1 produces self-inductance L1 equals to N1 phi I1 upon I1. I1 is the current, which in turn produces leakage reactance X1 is equal to 2 pi f L1. Similarly, secondary leakage flux phi I2 produces leakage reactance X2 2 pi f L2. The leakage reactance have been shown external to the winding. This. Now, the equivalent reactance. To make the calculations easy, the reactances of the two windings can be transferred to any one side. The reactance from one side to other is transferred in such a manner that percentage voltage drop remains the same when presented on either side. Let the primary reactance X1 be referred to the secondary and new value of this reactance X1 dash called equivalent reactance of the primary referred to secondary as shown in figure A. Then I2 x1 dash upon V2 equals to I1 x1 upon V1. Therefore, x1 dash equals to E square upon x1. Not E square, this will be K square upon K square into x1. This is the typing mistake. Therefore, total equivalent reactance referred to secondary will become X equivalent x2 plus x1 dash and it will be x2 plus k2 square x1. Now let us consider secondary reactance x2 when it is referred to the primary side. Its new value is x2 dash called equivalent reactance of the secondary referred to primary as shown in figure C. This one. This one. So in this case, I1 x2 dash upon V1 equals to I2 x2 upon V2. Therefore, x2 dash will become x2 upon k2 square and the total equivalent reactance referred to primary will become x1 plus x2 square upon k square. So thanks for watching. Take care and goodbye.